So welcome to another lecture in testing, and this lecture is about faults, errors, failures, infections, propagation, and testability. So a fault is a static flaw in a program. What we think of as a bug. Above me there is the original bug. That was an insect that got caught in a relay in one of the first computers. So a relay is an electrical switch which they used before we had transistors. So I've written a small code example over here. So this is the add method. It takes two arguments, A and B, and I've introduced a bug, a very stupid bug, because we should add something, but we actually subtract something because I used the minus operator. So the minus operator here is what I call a bug. It's a static flaw in a program. So a fault is that bug. It's the same thing, right? So next concept is error state. So an error state is that we get into an illegal state. So the state is the values of all variables or database or everything that has values in a program. So every variable, every database, every storage files, whatever, is the state of the program. So if we get in an illegal state, that is, we have the wrong value in some variable or in the database or in a file or whatever, then we're in a bad illegal program state. So the error state is when we have such a bad state. So if we call the add method here with the bug with a 3 and a 4, so 3 minus 4, since we had a bug which used the minus instead, becomes 1. So the variable sum gets the illegal value or the error state value of it's actually getting -1, right? So it's getting the illegal value of -1. So the sum is -1 while it should be 7. An important thing to realize when you do testing is that not every fault, not every bug always produces an error. So in this case, if I add 3 and 0, since it's 0, doesn't matter if it's plus or minus. So with that data, with that input, that test data, we get the same value. We get sum is not in an illegal state. And this is quite common. So if there are more complex code with a bit of for loops and whatnot, if we get an error state or not depends on the input of these methods or the input of the user. So you have probably been using programs that have bugs in those, but you never realized there were bugs because you didn't do anything that put the state in an error state. So, but in order for us to actually know if we have a bug or in the program, we also need to reach something that I call a failure. So failure is when we are able to observe the error state. So a failure is an observable incorrect behavior of a program. It results of an error state. So we call add at some point in the program, and then we have an error state, and then this error state propagates through the program. All these instructions are run with the sum and whatnot, and then if we output the sum so that the user can see it and we can read that on the screen perhaps, then we have a failure. So a failure is an observable incorrect behavior of a program. It's quite common that these error states are never producing any failures because they never surface, they never are produced as output, or we are not able to observe those because we don't look in the database. Perhaps they're stored in a database or in a file instead, and we never look there, and then we never notice that we have a bug in our program. And it's also the case that it's quite hard to observe the difference between these two colors. This is an example of that not every failure is actually observed, even if we could observe it. So we, as testers, we want to be able to observe failures, because then we can report this, that there is a bug somewhere in the program, and we can backtrace and debug and remove the bug, and then we get a better product in the end, right? But in the case here with the colors, there is actually a very small difference between these two color boxes. Probably not even noticeable on YouTube, but I just changed one of the values of one of the RGB values of these colors one step, and that is not enough for me, at least, to see the difference between these two colors. So we want to observe these, and we must be observable. So to find faults with test, first we need to be able to reach the test. We need to run the add method so that we can get an infected state, or can get an error state. So we actually must produce input into our program so that add is called if that is the location of the fault. So reachability is about that, and we need a reachability to get error states. So if an fault it results in an error state or not depends on if it infects the state into an error state or not. So we've already seen an example where it did not, where it did infect and where it did not infect the state. So the infection is that, yeah, it must change the program state in some way that is false, right, or wrong. In this case, we must call the add method with a non-zero value of the variable b. Then, finally, in order to find the fault, we need to the error or state needs to propagate to the surface where someone can observe it. So it must produce an incorrect output that is observable, an observable failure. So in this case, we must show the output of the add method to the user so that the user can, or the tester can, observe this. So a test case has a few goals. First is controllability. And controllability is that we need to steer the program to a point where that we would like to test. We need to make sure that add is called if that is the method we want to test. So it must reach the fault. We need to run the code with a bug. It should produce the error state and also make the error visible as a failure. We also need another concept, and that is observability. That is the ability to see what the program is doing, to observe the result of add. So if there is a place where we can look for the result of add, then we have observability of that bug. So we need both controllability and observability to get testability, and that is really what we want. So that is a quality of our process and our quality of our code if we have that. Finally, we also need to have knowledge of the requirements and the specification to understand what to test and to know the difference between a -1 and a 7 in the case of add, so that we can know that. Finally, and these are two things that comes from me, and this is the accuracy of the test, is that if we get a failure and we observe that and we know that there somewhere in our code there is a bug, we want the tests to be able to point directly to the place or the location of the fault. So we want to know that it's the add method, and preferably also the minus operator that is the bug. If we run the entire program and we just observe a -1 coming out instead of a 7, then we must debug and find our way to that error. If we have a unit test for just the add method, a single test for just that method, and that fails, then we know that, okay, the fault is in the add method. So that is the accuracy. We can point directly to the fault. Finally, and this is more for manual test cases perhaps, we also want traceability. If a test fails, we want to know which requirement does this test belong to. And if we have a lot of test cases, we want to know which requirements are tested by these test cases and which are not. So that is a traceability. We can trace from a test case to a use case perhaps, or another requirement, so that we know that, okay, this requirement has 5 test cases or something like that. Okay, conclusion. So a fault is a static bug that can lead to an error state if it's executed. We need reachability for that. The fault infects the state if the state is changed to an illegal one, an error state. For the error state to be detected, it must surface to something that is observable. And that is the failure and observability, of course. Finally, we as testers must observe and make a judgment that what we see is not what we expect. Okay, thank you.